When we're working with statics problems, there's a couple of idealizations that we need to know and we need to understand what we're working with. But first, an idealization is a way to simplify a problem. Now, in the real world, our goal is to approximate what's happening in the real world, but the real world is very complicated. There's a lot of different factors going on. So we come up with these idealizations that help us understand and learn a topic and simplifies our approximation. So the idealizations that I want to talk about now, and there's a few others, but we'll get to them later, are really we can deal with problems that involve particles, or we can deal with problems that involve objects modeled as rigid bodies. Now, when we're doing this, the ease of the problem changes. So the complexity of the problem, it's less when we're working with particles, and it's more when we're working with the rigid bodies. So the rigid bodies are not hard to work with, but there's more things we need to consider. So let's look at what we're doing with a particle. And a particle is assumed to be this point right here, and the particle is going to have a mass, so we can have some mass, but it has no dimensions. So we have a mass, but we have no dimensions. And we can apply forces to this. So I can have some force F1, I can have another force F2, and they're applied right at that point. I can have as many forces as I want. I could have F3, F4, whatever. Now, rigid bodies are a little different. Rigid bodies are going to have a mass, but they're also going to have dimensions to them. So again, I have some mass, but the difference is I have dimensions. That means this might have some width, this might have some height if I'm working in 2D, and it's going to matter where these forces are applied. So this force might be applied, if this is some F1, it might be applied some distance L from the ground, and I need to account for that. Or I might need to know how long this shape is for some part of the problem. Now, there's one thing you need to be careful of. I'm going to put a little careful sign. When you're working problems from the textbooks that you have, a lot of the times they're going to give you illustrations and diagrams, but the diagrams, if you're working with particles, are not just going to represent whatever you're working with a dimensionless point or a small dot. They are going to show the object as a car or a boat or a telephone pole or whatever. So if I have a car, because it's easy to draw, they're going to show this. This can also represent a particle. But the idea is it's a single point. So it has no dimensions. It doesn't have a height. It doesn't have a length of the car. It doesn't have a distance between the wheels. It's really saying, okay, I'm going to be representing this as a particle, and then if I have some forces that are being pulled on it, I'm really just applying that force at this particle. And you really need to pay attention to the problem. You have to look at the problem description, the illustration, if there's dimensions on the actual drawing, and that should give you a hint if you don't know if it's a particle or a rigid body. But typically in the standard engineering statics textbooks, it's pretty evident if you are working with rigid bodies or you are working with particles, because the chapter that you're working on will typically be a particle chapter or a rigid body chapter.